Hi everyone, welcome back to another Tech Decide video. In this one we are doing part 2 in the CSEC Physics Formula book series, and we're looking at relative density. So let's go. So let's start off with a definition of relative density. Relative density is the ratio of the density of a substance to the density of a reference, and the reference we usually use is water. It tells how dense this substance is when you compare it to the reference. A value that is greater than 1 means that the substance is more dense than the reference. If the value is less than 1, however, that means the substance is less dense than the reference that was used. So when we're looking at density as a whole, we can look at how it relates in terms of the settlement of liquids when you place them in a beaker. So for this one, I'm going to be pouring 3 liquids into my beaker. So we're seeing how the 3 liquids have settled into 3 distinct levels, and that's as a result of different densities. So an example would be if you pour water and oil in the same container. Oil will always settle on top while water will be at the base. So for this example, you have the blue one having the greatest density, and likewise it would have the largest relative density. And the one on the top would have the lowest density and also the smallest value for relative density. So that simply means the one in the middle now would be in between both in terms of both values. So whenever you see liquids in a container and you see them settling in distinct levels, that is as a result of a difference in density and similarly a difference in the relative density of the substance. So now let's look at the symbol for relative density. Now there are 2. You can either see the row with a subscript R, or you will see RD. So any of these 2 you will see or can be used to represent relative density. Now let's look at the formula for relative density. Now relative density is calculated by dividing the density of the substance by the density of water, or whatever reference is used. In symbols, it would look like that. Now, it's not preference that is in the denominator, it's actually subscript. So all of these are written as subscript. Substance and reference are written as subscripts. Now let's look at the SI unit for relative density. There is none. Relative density has no units because both the numerator and denominator has the same units, and so they would cancel out each other. So relative density is one of those quantities in physics that has no units. And a constant that you need to bear in mind when we're dealing with questions of density or relative density is the density of water. And like I said, that's usually the reference. So the density of water is 1,000 kilograms per cubic meter, or 1 gram per cubic centimeter. Okay? So now let's look at the application of relative density. Question 1 says, a substance has a density of 3,500 kilograms per cubic meter. Determine its relative density. And of course, first thing we do is to record what we got in the question. So I'm going to shorten it to density of substance, just sub. And then of course, remember we have the density of water as a constant. So now we put our formula and then plug in. Now we substitute. So naturally the units will cancel, and then we can factorize those zeros. So we end up with 3.5. So it means then that this substance is 3.5 times more dense than water. Let's go to question 2. The relative density of seawater is 1.03. What is the mass of seawater in a tank of volume 10 cubic meters? So let's record what we have. Okay, so now we have the density of seawater. We now need to plug that in our equation. So it asks us to find mass. Okay? So we're writing back our original density equation. Then we transpose. We would have seen in the last video that mass would be equal to density times volume. Just running out of a little bit of space here, but I'm making it work. So I just going to bracket it so we know that all of that is being multiplied. So we multiply that now. We get, and that would be the answer. So for this number 2, took us a little bit more, but what we had to do first, we got the relative density of seawater and the volume, and we were asked to calculate the mass. So we first had to find out what density seawater has, then now substitute that into the equation for density. But naturally we need mass, so we had to do a little bit of transposition, and then to arrive at our final answer, which is 10,300 kilograms of seawater. Now, of course, it's your turn. These questions are for you to try, and of course, I will put the link in the description so that you can see the answers to the questions. Thanks again for watching. I really hope this video was helpful. Remember to give the video a like, share because sharing is caring, and of course, subscribe. In the next one, we'll be looking at weight. So, see you then.